January 17, 1991. Qami's Mushat Air Base, deep in the Saudi Arabian mountains between Yemen and the Red Sea. Major Gregory A. Feast scanned the cockpit displays of his F-117 Nighthawk in absolute darkness. The moon had set. Layers of clouds blanketed Saudi Arabia and swirled northward into Iraq. The execute order for Operation Desert Storm had been transmitted to coalition air forces across the theater. H hour was set for 3 o'clock in the morning, Baghdad time. Major Feast, a pilot with the 415th Tactical Fighter Squadron of the 37th Tactical Fighter Wing, pushed the throttles on his left console forward to their stops, released the brakes, and felt the black jet lunge forward into the Arabian night. As runway lights flashed by on either side of the cockpit, he pulled back on the control stick and lifted the aircraft into the air. He was alone in the darkness, with only the lights of villages in the mountains and desert visible below him. His radios were switched on but remained soundless. No one would speak until after the bombs fell. 2 hours of flight time separated him from the most heavily defended city in the Middle East and possibly the world. Baghdad was protected by more than 3,000 anti-aircraft guns and 60 surface-to-air missile batteries, a layered integrated air defense system that the Soviet Union had spent decades perfecting and exporting to its most loyal client states. Iraqi commanders had publicly declared that no aircraft would survive passage through their defensive shield. They were certain of this. They had purchased the best systems Soviet technology could provide. Yet what the Iraqis did not know, what their radar operators could not see, and what their intelligence services had failed to anticipate, was that Major Feast was piloting an aircraft with a radar cross-section of just 0.003 square meters. That was equivalent to the radar signature of 3 insects. The F-117 Nighthawk, developed in absolute secrecy by Lockheed's Advanced Development Program's division known as Skunk Works, was the world's first operational stealth aircraft, and it was about to rewrite the rules of modern air warfare in a single night. The faceted geometry of its airframe, the radar-absorbent materials coating every surface, and the internal weapons bay designed to eliminate external protrusions had all been engineered with one singular purpose: to make the aircraft invisible to enemy radar. The Iraqis believed they were prepared for an air campaign. They had studied the Vietnam War. They had analyzed Israeli tactics over Lebanon. They had trained their radar operators to track fast-moving targets at high and low altitude. They had deployed SA-2 guideline missiles with a range of 27 nautical miles and an engagement ceiling of 89,000 feet. They had positioned SA-3 GOA batteries with flat-face radar guidance systems capable of tracking targets at 59,000 feet. They had installed mobile SA-6 gainful systems on tracked chassis, supported by robust straight-flush fire control radars that were difficult to deceive. They had placed SA-8 and Roland batteries at critical installations throughout Baghdad. They had integrated anti-aircraft artillery into a coordinated defense network designed to create an impenetrable curtain of fire over the capital. In their assessments, in their planning documents, in their public statements to the international press, Iraqi military officials expressed absolute confidence that their air defenses could destroy any aircraft that dared approach Baghdad. They were wrong. The arrogance of the Iraqi high command was not without reason. Their integrated air defense system was based on Soviet doctrine that had proven effective in previous conflicts. The SA-2 guideline, despite being developed in the 1950s, had enjoyed tremendous success during the Vietnam War, downing numerous American aircraft including high-altitude reconnaissance planes. The SA-3 GOA, introduced into Soviet service in 1963, provided longer range and better tactical mobility than its predecessor. The SA-6 Gainful had inflicted devastating losses on the Israeli Air Force when first employed during the October 1973 Yom Kippur War, demonstrating the lethality of modern surface-to-air missile systems when properly deployed and operated. Iraq had purchased these systems in substantial quantities, had trained operators at Soviet military academies, and had positioned them in overlapping coverage zones throughout the country. The defenses around Baghdad were particularly dense. 10 SA-2 batteries, 16 SA-3 batteries, 8 SA-6 batteries, 15 SA-8 batteries, and 9 Roland batteries ring the capital in a configuration designed to provide redundant coverage at all altitudes and approach vectors. Additional early warning radars positioned along the borders were intended to provide advance notice of incoming aircraft, allowing missile batteries to activate their engagement radars and prepare to fire. The entire system was networked through command and control centers that coordinated the defensive response. On paper, it was a formidable defensive architecture. Soviet military advisors had assured their Iraqi counterparts that the system would exact a heavy toll on any attacking force. Iraqi leaders believed them. They broadcast their confidence to the world. They warned that American pilots would face a death trap if they dared to strike Baghdad. They were certain that their Soviet-built systems would see everything coming. The Iraqi Integrated Air Defense System, known by the French acronym KARI, which stood for Iraq spelled backwards in French, was one of the most sophisticated networks ever deployed outside the Soviet Union itself. The system had been designed and partially installed by French defense contractors in the early 1980s, incorporating Soviet radar and missile hardware into a centralized command structure modeled on Western principles. The KARI network linked early warning radars, acquisition radars, tracking radars, surface-to-air missile batteries, anti-aircraft artillery positions, and fighter interceptor bases into a unified defensive architecture controlled from a hardened command center in Baghdad. The system was designed to provide redundant coverage across the entire country, with regional control centers that could assume command if the central facility was destroyed or communications were severed. Iraqi air defense commanders had invested years in training their personnel, conducting exercises, and refining their procedures. They had studied every air campaign conducted since the Vietnam War, analyzing what had worked and what had failed. They had adapted Soviet doctrine to incorporate lessons from the Israeli Air Force operations over Lebanon in 1982, where Syrian air defenses had been devastated by a combination of electronic warfare, anti-radiation missiles, and precision strikes. The Iraqis believed they had learned from those failures. They had positioned their most critical radars in hardened shelters. They had deployed mobile systems that could relocate after firing to avoid counter-battery strikes. They had established communication redundancies using both radio links and buried cables. They had created local backup networks that could operate independently if the central command structure was compromised. On paper, it was an impressive system. In practice, it was about to be rendered obsolete by technology the Iraqis had never anticipated. But they had never encountered stealth technology. They had never faced an aircraft designed from the first line of computer code to defeat radar detection. They had never imagined that an attacking bomber could slip through their defensive network without generating a single trackable radar return. The F-117 Nighthawk was not an incremental improvement over existing aircraft designs. It was a revolutionary leap that rendered traditional air defense doctrine obsolete. The development of this aircraft had begun more than a decade earlier, in the mid-1970s, when the United States Air Force recognized that advanced Soviet radar and surface-to-air missile systems threatened to make conventional non-stealthy aircraft obsolete in high-threat environments. The Defense Advanced Research Projects Agency, known as DARPA, initiated a program called Project Harvey, aimed at countering integrated air defense systems that posed a significant threat during conventional invasion scenarios. The challenge was given to Lockheed's Skunk Works, the legendary Advanced Development Division that had previously designed the U-2 spy plane and the SR-71 Blackbird. Under the leadership of engineers who understood that speed and altitude alone could no longer guarantee survival, the Skunk Works team pursued a radically different approach: invisibility through radar signature reduction. The result was Project Have Blue, a top-secret demonstrator program that tested the fundamental principles of stealth aircraft design. The Have Blue prototypes were bizarre-looking machines, with faceted surfaces and sharp angles that earned them the nickname Hopeless Diamond from skeptics within the team. The design philosophy was revolutionary. Instead of trying to absorb all incoming radar energy, the faceted surfaces were precisely angled to deflect radar waves away from the transmitting source. Using pioneering computer modeling developed by Skunk Works engineer Dennis Overholser, the team calculated the exact angles required to minimize radar returns. Overholser had discovered a Soviet research paper written by Russian physicist Pyotr Yefimtsev that described how to calculate radar reflection from simple two-dimensional shapes. Working on a Cray supercomputer, Overholser created software called Echo 1 that could predict the radar cross-section of complex three-dimensional objects by breaking them down into flat facets. The program revealed that a properly designed faceted aircraft could have an astonishingly low radar signature, orders of magnitude smaller than any conventional aircraft. Veteran designer Bill Schroeder translated these mathematical principles into an actual aircraft configuration, sketching a flyable design composed entirely of flat trapezoidal and triangular surfaces with no curves except for small radius edges on the wings and tail. The design looked alien, almost like a geometric sculpture rather than an aircraft, but the computer predictions indicated it would be nearly invisible to radar. Testing at a radar cross-section measurement range at White Sands, New Mexico proved that the design had the incredibly small radar cross-section it promised. A full-scale wooden mock-up of the aircraft, mounted on a pylon and illuminated by radar transmitters, returned signals so weak that technicians initially thought their equipment was malfunctioning. The aircraft was nearly invisible to radar. Ben Rich, who had assumed leadership of Skunk Works from the legendary Clarence Kelly Johnson in 1975, understood the profound implications of what his team had discovered. Rich had spent his entire career at Skunk Works, beginning as a thermodynamicist working on inlet designs for the F-104 starfighter in the 1950s. He had worked on the U-2, the SR-71, and numerous classified projects that pushed the boundaries of aerospace technology. But stealth represented something fundamentally different. It was not about flying higher or faster than the enemy. It was about becoming invisible, about rendering the enemy's most sophisticated sensors useless. Rich articulated the principle with elegant simplicity in his later writings. With flat surfaces, the amount of radar energy returning to the sender is independent of the target's size. A small airplane, a bomber, an aircraft carrier, all with the same shape, will have identical radar cross-sections. But if that shape is optimized for stealth, the radar cross-section can be reduced to near-zero levels. This was the breakthrough that would change air warfare forever. Rich secured funding for the Have Blue demonstrator program in April 1976, winning a competition against Northrop's rival design. The contract was worth approximately $10 million, a modest sum even by 1970s standards, but it represented authorization to proceed with the most revolutionary aircraft design in history. From that point forward, stealth development went deep into the black world of classified programs, hidden behind layers of security clearances and compartmented access restrictions that prevented even most senior military officers from learning about the project. Flight tests conducted at the clandestine Groom Lake facility in Nevada during 1977 and 1978 refined the design, improving the radar cross-section, the fly-by-wire flight control system necessary to control the inherently unstable airframe, and the overall aerodynamic performance. The Have Blue demonstrators were tiny aircraft, weighing less than 12,000 pounds fully loaded, powered by two General Electric J-85 turbojet engines borrowed from T-38 trainer aircraft. They were not intended to be combat-capable, but rather to prove that a faceted stealth aircraft could actually fly and that its radar signature would be as low as predicted. The test program was conducted under absolute secrecy at Groom Lake, the remote facility in the Nevada desert also known as Area 51, where the U-2 and SR-71 had previously been developed and tested. Pilots flew the Have Blue demonstrators exclusively at night, landing before dawn to minimize the chance of observation by Soviet reconnaissance satellites. The aircraft were hidden in hangars during daylight hours. Anyone approaching the facility without proper authorization was intercepted by security personnel long before they could observe anything classified. The test program validated every prediction the engineers had made. The aircraft flew, maneuvered, and demonstrated a radar cross-section so small that it was effectively invisible to contemporary radar systems. One Have Blue demonstrator was lost in a landing accident, and the second was damaged beyond repair in another mishap, but both losses occurred after the test program had gathered sufficient data to proceed with a production aircraft. The success of Have Blue led directly to a production contract for an operational stealth fighter. The result was the F-117A Nighthawk, developed under ultra-secrecy throughout the 1980s. The first production F-117 was delivered to the United States Air Force in August 1982. Operational capability was achieved in 1983, but the existence of the program remained classified for years. The aircraft was stationed at Tonopah Test Range in Nevada, a remote facility approximately 140 miles northwest of Las Vegas, where security was absolute and flight operations were conducted only at night. The Tonopah Test Range had been established in the 1950s to support nuclear weapons testing by the Atomic Energy Commission and had evolved into a multi-purpose facility managed by the Air Force for classified programs. Beginning in October 1979, Tonopah underwent major reconstruction specifically to support F-117 operations. The existing runway was lengthened from 6,000 feet to 10,000 feet and then to 12,000 feet. Taxiways, concrete aprons, maintenance hangars, and support facilities were constructed. Security fencing was installed around the entire complex. Housing was built for personnel, creating a self-contained community known as Mancamp where pilots, maintainers, and support staff lived during their duty rotations. The 4,450th Tactical Group, The unit designated to operate the F-117 moved from Groom Lake to Tonopah in 1983, equipped with a partial squadron of stealth fighters plus A-7D Corsair II aircraft that were used for pilot training while F-117 production continued. Pilots who flew the F-117 were forbidden from discussing their work even with their families. Cover stories were created to explain their absences and the classified nature of their duty. Personnel commuted weekly between Las Vegas and Tonopah on unmarked Boeing 737 aircraft operated by contractor EG&G, flights that became known as Janet flights. The veil of secrecy surrounding the program was impenetrable. Rumors circulated in the aviation press about a mysterious black jet being developed by Lockheed, but no confirmed photographs or specifications leaked until the Air Force publicly acknowledged the aircraft's existence in November 1988, more than 6 years after the first production F-117 had been delivered. 59 F-117A aircraft were built between 1981 and 1990, each one constructed by hand at Lockheed's facility in Burbank, California, and then flown to Tonopah for operational deployment. The aircraft coupled a powerful digital flight computer capable of maintaining control, despite its aerodynamically unstable configuration, with extreme survivability through its revolutionary stealth design. The entire airframe was coated with radar-absorbent materials that further reduced its already minimal radar signature. These materials, composed of various compounds including ferrite particles suspended in epoxy matrices, absorbed radar energy at specific frequencies rather than reflecting it back to the transmitter. The coating had to be applied carefully and maintained meticulously, as any damage or degradation could compromise the aircraft's stealth characteristics. The engines were buried deep within the fuselage, with specially designed exhaust systems that dissipated heat and masked the infrared signature. The exhaust was channeled through wide, flat nozzles that mixed hot engine gases with cool ambient air, reducing the thermal signature visible to infrared sensors. There were no external weapons pylons, no protruding antennas, no surface features that could generate radar reflections. Even the cockpit canopy was coated with a thin layer of conductive material that allowed the pilot to see out while reflecting radar waves. Every aspect of the design prioritized stealth over traditional performance metrics. The F-117 was subsonic, with a maximum speed far below that of conventional fighters. It was not agile in close combat. It carried only 2 bombs in its internal weapons bay. But none of that mattered, because the F-117 was not designed to dogfight or to outrun missiles. It was designed to penetrate the most heavily defended airspace in the world, strike high-value targets with precision-guided weapons, and escape without ever being detected. Standard mission preparation for F-117 pilots could take 6 hours or more. Pilots studied intelligence photographs of their assigned targets, memorizing every detail of the target area including approach landmarks, defensive positions, and escape routes. They programmed navigation waypoints into the aircraft's mission computers, calculating precise times and altitudes for each segment of the flight. They reviewed contingency procedures for every possible scenario, from mechanical failures to defensive reactions. They studied weather forecasts, intelligence updates on enemy air defenses, and the locations of friendly forces. They coordinated with tanker aircraft that would provide aerial refueling before and after the strike. They rehearsed the weapons delivery sequence, calculating the exact time to open the weapons bay doors, designate the target with the infrared targeting system, and release the bombs. The level of preparation required for each mission was exhaustive, reflecting both the complexity of the aircraft systems and the unforgiving nature of operations in heavily defended airspace. Pilots trained for years before being certified combat-ready in the F-117, progressing through increasingly complex scenarios that tested their ability to navigate precisely, operate the targeting systems accurately, and react appropriately to unexpected situations. The training was conducted at night, matching the operational profile the aircraft would fly in combat. Pilots flew without lights, without radio communication except in emergencies, and without formation support. Each F-117 mission was flown solo, with the pilot responsible for every aspect of navigation, targeting, and weapons delivery. This placed enormous demands on pilot skill and discipline, but it also minimized the chance of detection by eliminating the coordination and communication that would be required for multi-ship formations. The F-117 had first seen combat during Operation Just Cause on December 19, 1989, when two aircraft from the 37th Tactical Fighter Wing attacked military targets in Panama during the American intervention to remove Manuel Noriega from power. The F-117s struck a Panamanian Defense Force barracks near Rio Hato using GBU-27 laser-guided bombs, demonstrating the aircraft's precision strike capability in an actual combat environment. The operation was a success, although post-mission analysis revealed that the bombs had missed their precise aim points by several hundred feet due to challenging target conditions and the pilots' cautious approach to weapons delivery in their first combat mission. The Panama operation was limited in scope and did not involve penetrating sophisticated air defenses, so it provided only a partial test of the F-117's capabilities. The aircraft had proven it could strike targets accurately and return safely, but the question of whether it could penetrate a prepared integrated air defense system similar to those defended by the Soviet Union and its allies remained unanswered. That test would come in Iraq, and the stakes would be infinitely higher. In August 1990, following Iraq's invasion of Kuwait on August 2nd, the 37th Tactical Fighter Wing deployed en masse to Saudi Arabia as part of Operation Desert Shield, the defensive buildup designed to deter further Iraqi aggression and prepare for potential offensive operations to liberate Kuwait. 22 F-117s departed Tonopah Test Range on August 19, 1990, flying first to Langley Air Force Base in Virginia for crew rest and coordination, then continuing across the Atlantic to Saudi Arabia. 18 aircraft ultimately deployed to Qami's Mushat Air Base, a secure location in southwestern Saudi Arabia far from the Kuwaiti border where the F-117s could be protected from Iraqi reconnaissance and potential attack. The deployment represented the largest movement of F-117 assets since the aircraft became operational, and it marked the transition of the stealth fighter from a highly classified black program to an acknowledged but still secret operational capability. Hundreds of support personnel from Tonopah deployed alongside the aircraft, bringing specialized maintenance equipment, spare parts, and the radar-absorbent coatings required to maintain the aircraft's stealth characteristics in the harsh desert environment. Hardened aircraft shelters at Qami's Mushat provided protection for the F-117s during daylight hours, while maintenance crews worked around the clock to prepare the aircraft for the coming war. Throughout the fall and winter of 1990, as coalition forces built up in Saudi Arabia and diplomatic efforts to resolve the crisis continued at the United Nations, F-117 pilots trained for the missions they knew were inevitable. They studied Baghdad's air defenses in exhaustive detail, analyzing satellite imagery, signals intelligence, and human intelligence reports to map every known radar site, missile battery, and anti-aircraft gun position. They identified critical targets, command and control centers that coordinated Iraq's military operations, communications facilities that linked Iraqi forces across the theater, hardened bunkers where Iraqi leadership might shelter during airstrikes, air defense headquarters that controlled the KARI network, research and development installations associated with Iraq's nuclear and chemical weapons programs, and key infrastructure nodes whose destruction would cripple Iraq's ability to sustain military operations. They planned ingress and egress routes that would minimize exposure even to visual observation, threading through gaps in radar coverage and avoiding areas where anti-aircraft fire would be densest. They calculated fuel requirements, weapons loads, and timing sequences with obsessive precision, and they waited for the order to strike. The pilots understood that they would be leading the air campaign, striking into the heart of Baghdad while conventional aircraft attacked targets throughout Iraq and Kuwait. The responsibility was enormous. If the F-117 failed to penetrate Iraqi air defenses, if aircraft were lost to missiles or anti-aircraft fire, if the stealth technology proved less effective than predicted, the entire air campaign strategy would collapse. The pressure on the F-117 community was immense, but confidence in the aircraft and its capabilities remained high. The pilots had trained for this mission for years. They knew their aircraft, they trusted the technology, and they were ready. That order came in January 1991, when diplomatic efforts to resolve the crisis failed and President George H.W. Bush authorized military action to liberate Kuwait. The opening phase of Operation Desert Storm was planned as a coordinated air campaign designed to destroy Iraq's air defenses, command structure, and strategic infrastructure in the first hours of the war. F-117 Nighthawks would lead the attack, striking the most critical targets in Baghdad itself, while conventional aircraft suppressed air defenses elsewhere and attacked secondary targets throughout the theater. The timing was precise. choreographed down to the second to ensure that different elements of the strike package would hit their targets simultaneously, overwhelming Iraqi defenses and preventing a coordinated response. Coalition aircraft would cross into Iraqi airspace in waves, with F-117s penetrating to Baghdad, F-15E Strike Eagles and F-111 bombers attacking airfields and military installations, EA-6B Prowlers and EF-111 Ravens jamming Iraqi radars and communications, F-4G Wild Weasels firing anti-radiation missiles at radar sites, and hundreds of other aircraft executing their assigned missions across a front stretching from the Kuwaiti border to northern Iraq. But the F-117s would go first, alone, into the heart of Baghdad, striking the targets that mattered most before the Iraqis fully understood they were under attack. Major Feast and the other F-117 pilots taking off that night understood the stakes with absolute clarity. They were flying into the most heavily defended city in the theater, a capital whose air defenses were on full alert and expecting an attack. Intelligence assessments warned that Iraqi radar operators were tracking coalition tanker aircraft orbiting over the Saudi border, timing the intervals between tanker activity and potential strike windows. The Iraqis had concluded correctly that the invisible bombers everyone was talking about would need to refuel before crossing into Iraqi airspace, and they planned to use the tanker activity as a warning indicator. When the tankers turned away from the border, Iraqi air defense crews would assume that F-117s had crossed into their airspace and were inbound to Baghdad. They planned to start firing surface-to-air missiles blindly into the sky along predicted approach corridors, hoping to hit something they could not see on radar. It was a desperate tactic, born of the realization that their radar systems were inadequate, but it was also dangerous. Even an aircraft that could not be tracked on radar could still be hit by a missile fired into its flight path, either through sheer chance or if the missile's proximity fuse detected the aircraft passing nearby. The F-117 pilots knew this. They knew that Iraqi gunners would fill the sky over Baghdad with anti-aircraft fire and missiles. They knew that one lucky hit could bring down their aircraft. And they knew that if they were shot down over Baghdad, in the heart of enemy territory with no rescue forces able to penetrate that far into Iraq, survival and rescue would be unlikely. Capture would mean interrogation, propaganda broadcasts, and potential execution. But they also knew that the F-117's stealth capabilities gave them an advantage that no other aircraft possessed. They would be invisible until the bombs exploded. They would strike before the enemy even knew they were there. That advantage, combined with precise mission planning and disciplined execution, would give them the edge they needed to survive. The small black jets, as they were called by the pilots who flew them, had to sneak past Iraq's border radar defenses, and the timing was calculated so that they would be right over Baghdad when the air war officially kicked off at 3 o'clock in the morning local time. Each aircraft carried 2 GBU-27 Paveway III laser-guided bombs, precision weapons specifically designed for delivery by the F-117 and optimized for penetrating hardened structures. The GBU-27 was a modification of the earlier GBU-24, adapted to fit within the F-117's internal weapons bay and integrated with the aircraft's sophisticated targeting systems. The bomb used a BLU-109 warhead, a 2,000-pound penetrator developed in 1985 under the classified program name Evasion. The BLU-109 featured a high-strength forged steel case designed to punch through reinforced concrete and hardened structures before detonating. It carried 550 pounds of high explosives and could penetrate more than 6 feet of reinforced concrete, making it ideal for striking bunkers, command centers, and other hardened targets. The GBU-27 guidance system used a modified Paveway II control unit that provided terminal trajectory shaping, allowing the bomb to adjust its approach angle for optimum effect against different target types. Against an aircraft shelter, the bomb would strike vertically, maximizing penetration. Against a bridge support, it would approach horizontally to maximize structural damage. Against a hardened bunker, it would dive steeply to penetrate the roof before detonating inside. The guidance system used reflected laser energy to steer the bomb to its target, with the F-117's infrared targeting system providing the laser designation. Each F-117 could carry 2 of these weapons, one in each side of the internal weapons bay. The weapons release sequence required the pilot to open the bay doors, acquire the target through the infrared targeting system, designate the aim point with a laser, verify that the weapon had achieved lock-on, and release the bomb. The weapon would then guide itself to the target, correcting its trajectory in flight to ensure a direct hit. The entire sequence from bay door opening to weapon release would take only seconds, after which the pilot would close the bay doors and turn away from the target area. But those few seconds when the bay doors were open represented a vulnerability that could not be eliminated. The weapons bay, when exposed, created a cavity that could reflect radar energy back to enemy receivers. If Iraqi radar operators happened to be scanning in the right direction at precisely the right moment, they might detect a brief radar return that would indicate an aircraft was overhead. It was a calculated risk, one that could not be avoided if the mission was to succeed, but one that the pilots were acutely aware of every time they opened those bay doors over enemy territory. If you appreciate discovering the classified operations and secret technologies that changed the course of modern warfare, consider subscribing to Classified Warfare for future revelations from the hidden conflicts of the Cold War era and beyond, where intelligence, deception, and breakthrough technology determine the balance of global power. Major Feast crossed into Iraqi airspace at low altitude, threading his way through gaps in the radar coverage that intelligence analysts had identified during months of surveillance and analysis. Behind him, separated by time and distance, other F-117 pilots followed their own routes toward their assigned targets. Each aircraft operated independently with no formation flying, no mutual support, no radio communication except in the most dire emergencies. Each pilot was alone with his mission and his aircraft, responsible for navigating precisely to his target, delivering his weapons accurately, and returning safely to base. The flight north toward Baghdad took nearly 2 hours, with the F-117 cruising at altitudes and airspeeds calculated to balance fuel efficiency against the need to reach the target on time. The F-117's navigation system used a combination of inertial guidance and periodic updates from terrain-following radar measurements to maintain accurate position information without emitting detectable signals. The aircraft flew through darkness, invisible to the sensors desperately searching for it. Iraqi radar operators watched their screens in command centers and missile battery control vans scattered across the country, seeing nothing unusual. Early warning radars positioned along the borders detected no incoming aircraft. Acquisition radars designed to search large volumes of airspace for potential targets showed empty screens. The integrated air defense network, despite its sophistication and redundancy, was blind to the approaching threat. In Baghdad, air defense crews waited at their posts, expecting an attack but seeing no indication that one was imminent. They tracked the coalition tanker aircraft orbiting over Saudi Arabia, noting their positions and movements. They calculated the likely time window when stealth aircraft might cross into Iraqi airspace based on tanker activity, and then they waited, fingers on triggers, ready to fire at targets they could not see, hoping that blind firing and sheer volume of fire might achieve what their sophisticated radar systems could not. At precisely 3 o'clock in the morning Baghdad time, the first bombs fell on the Iraqi capital. Major Feast's 2 GBU-27 laser-guided bombs slammed into their target, a critical command and control facility that coordinated Iraqi air defense operations across the central region. The explosions lit up the night sky, fireballs erupting from the impact points as the penetrating warheads detonated inside the hardened structure. Iraqi radar operators, who had been staring at blank screens showing no incoming aircraft, suddenly realized they were under attack. Their most advanced surface-to-air missile systems, including SA-2, SA-3, and Roland batteries positioned specifically to defend Baghdad, had provided no warning whatsoever. The bombs exploded without any radar indication that aircraft were overhead. The first indication of attack was the explosions themselves. It was impossible. It violated every principle of air defense doctrine that Soviet advisors had taught them. Radar was supposed to provide early warning. Integrated air defenses were supposed to detect, track, and engage attacking aircraft before they reached their targets. That was the entire purpose of the system. And yet bombs were falling on Baghdad without any warning, without any radar contact, without any opportunity to engage the attacking aircraft. Within minutes, additional explosions rocked Baghdad as other F-117s struck their assigned targets throughout the city. Communication centers were destroyed, severing the links that connected the central command facility to regional control centers and individual missile batteries. Hardened bunkers housing Iraqi military leadership collapsed under the impact of precision-guided weapons that punched through meters of reinforced concrete before detonating inside. Air Defense Headquarters facilities were obliterated before they could coordinate a coherent response to the attack. Telephone exchanges and communications nodes were destroyed, fragmenting the command structure and preventing Iraqi commanders from issuing orders or gathering information about what was happening. The Iraqi command structure, which depended on centralized control through a rigid Soviet-style hierarchy and reliable communications linking all elements of the defense network, began to fragment under the devastating precision of an enemy that could not be seen or tracked. Commanders could not reach their subordinates to issue orders or gather situation reports. Air defense batteries could not communicate with each other or with higher headquarters to coordinate their defensive fires. The integrated air defense system, which depended on disciplined adherence to doctrine, centralized coordination, and reliable information sharing, was being systematically dismantled by an enemy that remained invisible to every sensor the Iraqis possessed. Iraqi gunners, desperate and confused and terrified by explosions erupting across their capital without any indication of where the attacking aircraft were, or when the next bomb would fall, began firing anti-aircraft artillery into the sky in massive uncoordinated barrages. Tracers arced upward into the darkness from hundreds of gun positions scattered throughout Baghdad, creating spectacular displays of firepower that looked dramatic but hit nothing. Surface-to-air missile batteries launched their weapons blindly, without radar lock, without target track, without any guidance information beyond the general direction from which they believed the attack might be coming. Missiles streaked through the night sky, their rocket motors creating brilliant trails of light visible for miles, but they had no target to track and no way to guide to an aircraft they could not detect. They flew until their fuel was exhausted, then fell back to Earth without hitting anything or triggered their self-destruct mechanisms when their internal timers expired. The F-117 pilots, watching from their cockpits as the sky around them filled with anti-aircraft fire and missiles and tracers creating a spectacular but ineffective light show, maintained their focus on their missions with disciplined calm. They acquired their targets through their infrared targeting systems, designated the aim points with their lasers, verified weapon lock-on, released their weapons, and turned away from Baghdad to begin their egress back to Saudi Arabia. The entire attack sequence, from the first bomb impact to the last F-117 departing Iraqi airspace, lasted less than an hour. Not a single F-117 was hit by enemy fire. Not a single aircraft sustained battle damage from missiles or anti-aircraft guns. The Iraqis fired hundreds of surface-to-air missiles and tens of thousands of anti-aircraft rounds into the sky over Baghdad that night, creating the most intense defensive barrage since the Vietnam War, and they hit absolutely nothing. The stealth fighters returned to their base at Qami's Mushat, landed safely without incident, and immediately began preparing for the next night's missions. The maintenance crews swarmed over the aircraft, inspecting them for any damage, replenishing fuel and weapons, touching up radar-absorbent coatings where necessary, and ensuring every system was functioning perfectly for the next sortie. The pilots who flew those first strikes into Baghdad would later describe the experience as surreal, almost dreamlike in its unreality. They had flown into the most heavily defended airspace in the world, penetrated directly over the heart of the enemy capital, struck critical targets with precision weapons, and returned without ever being engaged by enemy fire in any meaningful or targeted way. The anti-aircraft fire and missiles they observed were unguided, desperate attempts to hit something, anything, in the desperate hope that blind firing and sheer volume of ordnance might achieve what radar-guided systems could not. It was, in the words of one pilot interviewed after the war, like being invisible, like being a ghost that could strike without warning and disappear without trace. The Iraqi gunners were firing at empty sky, at where they thought aircraft might be, at where doctrine told them aircraft should be, but never at where the F-117s actually were. The sensation of watching missiles launch from the ground and arc upward, watching their rocket motors burn out, watching them fall back to Earth or detonate harmlessly thousands of feet away, all while sitting in the cockpit of an aircraft that the enemy could not see and could not track, was profoundly strange. The pilots had trained for years for these missions. They had studied the threat. They had rehearsed their procedures until they could execute them flawlessly even under stress. But nothing in their training had quite prepared them for the psychological experience of being truly invisible to an enemy that was desperately trying to kill them. The confidence in their aircraft and its stealth technology, which had been high before the war, became absolute after that first night. The F-117 had performed exactly as designed, exactly as predicted, penetrating the most sophisticated integrated air defense system outside the Soviet Union itself and striking high-value targets without loss or damage. The performance of the F-117 during the opening night of Operation Desert Storm validated every claim that had been made about stealth technology by its advocates and developers over the previous decade. Iraqi air defenses, which had been designed and deployed specifically to counter American air power based on Vietnam War experiences and analyses of Israeli operations over Lebanon proved completely ineffective against an aircraft they could not detect. The radar systems that formed the backbone of Iraq's integrated air defense network, all of which were Soviet-designed and had been fielded between 1955 and 1970, simply could not generate tracking quality returns from the F-117's minuscule radar cross-section. The SA-2 guideline, with its fan-song fire control radar operating at frequencies between 2 and 3 GHz, saw nothing. The SA-3 GOA, with its flat face and low-blow radars operating at slightly higher frequencies, saw nothing. The SA-6 Gainful, with its more sophisticated straight-flush radar that had proven so deadly against Israeli aircraft in 1973, saw nothing. The SA-8 Gecko and the Franco-German Roland, both newer systems with more modern radar technology, saw nothing. All of these systems shared a fundamental limitation that rendered them useless against the F-117. They required radar contact with sufficient signal strength and duration to establish a tracking solution and generate fire control data for missile guidance. Without that radar contact, without the ability to detect and track the target, the missiles could not guide to their intended victims. The F-117 exploited this fundamental vulnerability with devastating effectiveness. Its faceted geometry and radar-absorbent coatings scattering and absorbing radar energy so efficiently that it generated returns below the detection threshold of every radar system the Iraqis possessed. The aircraft slipped through radar coverage that the Soviet Union had spent decades developing and perfecting, striking targets that Iraqi commanders had believed were invulnerable to air attack, demolishing the assumption that centralized air defenses could protect high-value assets from determined assault. The psychological impact of this invisible threat on Iraqi air defense crews was profound and demoralizing. Crews who had been confident in their systems and their training, who had believed their Soviet instructors and their own commanders when told that the KARI network could defend Baghdad against any air attack, now faced an enemy they could not see, could not track, and could not engage. The frustration and fear generated by this realization degraded the effectiveness of the entire air defense network far beyond the physical damage inflicted by precision strikes against command centers and communications facilities. Morale collapsed among air defense personnel who realized their sophisticated equipment was useless against the American stealth fighters. Crews began to doubt their equipment, their training, and their orders. Some units shut down their radars to avoid being targeted by American anti-radiation missiles that homed in on radar emissions, which further degraded the defensive network by creating gaps in coverage. Other units fired blindly into the sky, wasting precious ammunition on targets that were not there, depleting their missile inventories without achieving any results. Discipline began to break down as individual battery commanders made independent decisions without coordination or authorization from higher headquarters. The integrated air defense system, which depended on centralized control and disciplined adherence to Soviet-style doctrine, began to disintegrate under the psychological pressure of an invisible threat that could strike anywhere at any time without warning. By the second and third nights of the air campaign, many Iraqi air defense units had effectively ceased functioning as coherent elements of an integrated network, either because their equipment had been destroyed by coalition strikes or because their crews had abandoned their positions out of fear and demoralization. Throughout Operation Desert Storm, which lasted from January 17 to April 6, 1991, when Iraqi President Saddam Hussein accepted ceasefire terms following the coalition ground offensive that liberated Kuwait, the F-117A Nighthawk conducted more than 1,271 sorties over Iraq and Kuwait. Although only 36 stealth fighters were deployed to the theater during Desert Storm, accounting for just 2.5% of the total force of approximately 1,900 fighters and bombers in the coalition inventory, they flew more than a third of the bombing runs on the first day of the war, and continued to strike the most critical, most heavily defended targets throughout the 6-week air campaign. The F-117s were assigned targets that conventional aircraft could not reach without suffering prohibitive losses. Hardened command bunkers in downtown Baghdad, communications facilities surrounded by dense air defense concentrations, chemical and biological weapons research installations protected by multiple layers of missiles and anti-aircraft guns, nuclear weapons development facilities that intelligence indicated might be producing components for Iraqi nuclear weapons, leadership bunkers where Saddam Hussein and his senior commanders might be sheltering. and critical nodes of the Iraqi command structure, whose destruction would cripple Iraq's ability to conduct coordinated military operations. The F-117 struck these targets night after night with an 80% mission success rate, a remarkably high figure given the difficulty of the targets and the challenging operational environment. They operated with impunity over the most heavily defended portions of Iraq, flying night after night into hostile airspace, delivering their weapons with precision that would have been impossible just a generation earlier, and returning to base without losses or significant battle damage. The aircraft dropped more than 2,000 tons of bombs during Desert Storm and flew more than 6,900 hours, an intensive operational tempo that tested both the aircraft and the maintenance crews supporting them. The Iraqis never shot down a single F-117 during the entire Gulf War. This perfect combat record was not for lack of Iraqi effort or determination. By the end of Operation Desert Storm, Iraq had fired more than 2,000 surface-to-air missiles at suspected or actual F-117 targets, and none of them achieved a hit. The anti-aircraft guns defending Baghdad and other Iraqi cities expended countless thousands of rounds into the night sky, creating spectacular but entirely ineffective displays of firepower that were captured by news cameras and broadcast worldwide, giving television audiences the misleading impression that Iraqi air defenses were putting up fierce resistance, when in reality they were firing blindly at an enemy they could not see. Iraqi intelligence officers interrogated captured coalition air crews, seeking any information about American stealth technology, operational tactics, aircraft capabilities, or defensive vulnerabilities. Documents captured after the war when coalition forces occupied Iraqi military installations revealed that Iraqi commanders had issued recognition guides to their fighter pilots, attempting to help them identify and intercept the F-117 if visual contact was somehow achieved. One of these documents, discovered by American intelligence analysts examining captured Iraqi Air Force materials, featured the silhouette of the B-2 Spirit strategic bomber instead of the F-117, indicating that Iraqi intelligence services had confused the two American stealth platforms and did not have accurate information about the specific aircraft they were facing. This intelligence failure reflected the extraordinary secrecy that had surrounded American stealth programs and the effectiveness of operational security measures that had prevented detailed information about F-117 capabilities from leaking to potential adversaries. Join us here at Classified Warfare as we continue to uncover the classified operations, breakthrough technologies, and secret battles of the Cold War and beyond that kept the world on the brink and forever changed the nature of global conflict.